Hi, in this video we're gonna continue to explore an SDF image asset. We left off with a sample sprite, scene and a material. Together with the package comes some samples. They can be found in Package Manager. Samples will be installed here. Let's open up the first scene with import settings. It will require some TextMesh Pro essentials, and after installation and scene reload, you can see the text. This scene describes some import settings, configurations, because there are multiple ways you can import your images. I'm not gonna dive much into detail about it now, but this is the topic basically that we're gonna be covering in this video. All types of the import, which is the best practices, so on and so forth. If we explore the samples folder further, you can see that all the store graphic are here. You can play around with the material values, check out the import settings, and overall get familiar with the asset. For now, let's come back to the sample scene. I'm gonna make a background real quick. In last video, I shown how to quickly import SDF with this toggle in the header, but different images requires different import settings, and import settings can be observed through SDF Importer. So, I'm gonna be explaining all of the importer fields. First off is target texture. This is the link to original texture, pretty straightforward. Second is generated SDF. This is the texture that we generating from original. It stores as nested asset inside of the original texture. Next field is final SDF resolution, which is 76 by 76 right now. That's 48% from the original texture. Also, this data, we can see it in image inspector at the bottom. The original sprite is 512 by 512, and generated SDF is 76 by 76 pixels. In order for SDF to work, it doesn't need to be the full resolution of the original texture. Right here, we're using the 10% of the original texture. Let's go to the render tab and explore how different values of resolution scale property is affecting our final rendered quality. Let's try to increase the resolution scale up to 1. And as you can see, the rendered SDF is pretty accurate. But if we decrease it up to 1%, then it doesn't really look right. Basically, generated SDF is just 7 by 7 pixels. That's really small. Here in SDF Importer, there is an extract SDF button, which will generate the copy of SDF as separate asset. We can explore it, and yeah, as you can see, that's really small. There's just a few pixels. This is not enough to render a quality SDF. Let's go back to engine, and yeah, as you can see, this outline is not really good. Let's try to gradually increase resolution scale. At 2%, it starts to resemble it's better. 3% is almost good. And the further we increase it, better it becomes. But at some point, there will be just no difference. The default value for resolution scale is 10%. This is usually enough for all of the pictures. There are some cases where your picture has really small details, some complex geometry, then you should increase your resolution scale. This image is an example of more complex geometry, smaller details, and so with resolution scale of 10%, we have some SDF artifacts. Like for example, this columns has no gaps, arrows looking kind of jagged, this hole here is weird, so we probably should increase our resolution scale. The fastest way to iterate over our import settings changes is to check our preview tabs. And to iterate resolution scale, we could use main width at the material and see is there any artifacts appearing depending on our width. With 20%, this image looking kinda nice with all widths, so I'm gonna left it at that. Okay, with resolution scale figured, let's go over some next SDF import settings. First off is this generate SDF checkbox. It's the same as in the header, really simple, whether we want to generate an SDF or not. Second parameter is border offset. It's somehow connected to resolution scale, because if we bump the resolution scale up to 1 and border offset to 0.5, we can see that our final SDF resolution is bigger than the original image. This 0.5 is basically 50% of original image resolution added to the final SDF texture. Why do we need this kind of thing? Let's extract an SDF image with 0.5 border offset and with 0 and open it in Photoshop. This is the border offset of 0. As we can see, it's 51 by 51 pixels. And what is its problem? If we increase the canvas size, we can see how sharply edges of the image ends. Pixels just literally been cut off. We have no data here, but there should be. Unfortunately, due to the lower size of the image, we can't really add much pixels there. Because the original image, it has just no corners. It's tightly packed. So we can't really add any data here. That's why border offset exists. This is the image with border offset of 0.5. As you can see, there is still space. There's no sharp edges. All pixels are nicely there. No data being cut off. In this scene, we can see how 0 and 0.5 values of border offset affects the final result. On SDF image, we should correspondingly change the mesh scale depending on our border offset. Basically, mesh scale is just 1 plus border offset. So if we set border offset to 0, then our mesh scale should be just 1. However, as you can see, SDF on the edges is being cut off. This is because our original image have no edges, have no offset to the edges. There is no space for SDF to generate its pixels. There is two ways to approach this problem. First is manually increase the size of the image given its offsets from the edges. I will do this in Photoshop, just manually drag some canvas size. And now we have some extra space between edge of the sprite and edge of the actual texture. This is the space where SDF texture can be generated. Also, in order for this technique to work, you should set your mesh type on sprite to full rect, so the mesh wouldn't be cut off. It's already pretty good, but we can see some artifacts at the top. So let's increase the canvas size even more. Yes, now the artifacts are gone. What's the problem with this approach? You always want your sprite to take some defined space on your screen. Like for example, this one is 400 by 400 units. However, because we added offset, the actual sprite looks smaller, because it is. And if we disable the SDF, there is just so much blank space. You can manually increase the size of the sprite, like overflowing the mesh, making it bigger. But this just doesn't really cool for singular textures. It's pretty inconvenient workflow. The second approach is to just in import settings bump up the border offset. This fixes the problem and original image remains intact. You, however, should increase the mesh scale on the SDF image, but overall, this is the better pipeline because your image takes whole space and then the SDF effect is just the addition to this space. It's additive to the size of image you already have. While we're here, let me explain how mesh scale works. So basically, SDF Image renders on the two separate quads. There is one quad rendering in front, which is the original sprite. Its size remains always the same. And there is the second quad behind it. This is where SDF rendered. And by pumping the mesh scale, you're basically just increasing the size of this quad behind. This is similar to how shadows and outlines adds additional quads. However, for SDF, it's just only one quad, not 5 or 10. So let's continue to explore the import settings. We already covered these three: generate SDF, border offset, and resolution scale. Next one is generation backend. There is two backends right now, but basically just one. The default is legacy. It generated on the GPU, so it's really fast. However, there is one artifact on the Mac with M1 processors. For some reason, here in the corner, there is some weird, just bunch of pixels. This problem would be approached in the future. And there's the original backend. Basically, it will just generate the original texture, which you can apply some border offset or resolution scale. Back to the legacy GPU backend. It reveals property called gradient size. Basically, it's how big your SDF effect will be. Let's compare the 0.1 value and 0.4 value. You already can see that 0.1 makes your SDF real small, but I'm gonna extract the images and compare them in Photoshop. This is the picture with 0.1 gradient size. As you can see, this is basically the edge of sprite, and SDF doesn't really goes any further than it. It's really small. It reassembles the picture edges really sharply. And this is 0.4. We already can't see the sharp edge. It's really blurred and it's bigger. The best practice is actually to use the same value around the default, so around 0.2. And then you can adjust it a little bit depending on the size of your image. Because different resolution of the images might give a different final width of the SDF. If you want to display textures with different resolutions in the same SDF image, then you should probably adjust their gradient size to match. But overall, you can change width of your effect with SDF multiplier at SDF image itself. So, we pretty much covered everything. There is an apply button, extract button, reset to defaults button. Also in the toolbar, there is select all SDFs button. If we press it in the project view, will be displayed all of the generated SDF texture. Unfortunately, there is no preview in multi-edit mode. If you select one of the textures and then clear the search bar, you can see what the original texture it belongs to. Also, let's go over other preview tabs in SDF Importer. There is a raw tab, where just plain texture displayed. There is a render tab, where SDF texture rendered using material. Next up is sprite tab. There you can see each individual sprite with some additional SDF image settings like color, SDF color, multiplier, and other checkboxes to render SDF or not. So that's pretty much it. Today we covered the SDF importer, all of the import settings, all of the tabs. And the last thing I want to show is where all the import settings is actually saved. If we open the texture in Explorer and go to its meta file, scroll down to the section called user data. This is where all the settings is saved. This is an important thing. You should be aware of that because some other assets might also use it, and then this section would just be overridden. Unfortunately, Unity does not provide any better way to save some metadata right now. In the future, they plan to release module importers, but they're not out yet. In next video, we're gonna cover multiple sprites workflow when you have multiple sprites on one texture. Also look more in depth onto the material settings, as well as SDF image settings, particularly the different image types, sliced, styled, filled, etc. So, see you next time. Thanks for watching.